Okay, the iron product rule. Now this is where we get into calculations, and this is where you need to probably put your most attention into with acids and bases, because this is where most of the problems happen with calculations, because for some reason people just don't like maths. Anyway, moving on. Acids and bases. With acids have lots of H pluses because that's what they do. They donate H pluses. They give off H plus. And bases, they have OH negatives, so they have the hydroxides. In a solution, the amounts of each are proportional to each other, and they can be calculated using a certain rule. Because something's been found out experimentally, you don't really need to know the details of it. If you want to, read the textbook by all means, but what you need to know is this rule, which is called the ion product rule. It's the fact that in any solution, the concentration of hydroxide multiplied by the concentration of hydrogen will equal 10 to the power of negative 14 molar squared. This has been found out experimentally, as I said. If you want to know more, read the textbook or ask me and I can talk to you about it anyway. But that's in any solution, and obviously if you get more hydrogen, you'll have less hydroxide. If you get more hydroxide, you'll have less hydrogen. But in any solution, this is true, that if you multiply the hydroxide by the hydrogen, you'll get 10 to the power of negative 14. And this is known as the ion product rule. What does this mean in terms of pH? It means, I won't go into that yet, I'll just tell you what pH is. The pH scale is basically a measure of how much hydrogen, the hydrogen ion, is in a solution. It's a log scale about the amount or the concentration of hydrogen in a solution. It's worked out by pH is equal to the negative log to the base 10 of the hydronium or hydrogen or proton in solution. So all you need to do with a calculator is type in negative log whatever the concentration of hydrogen is in your solution, and you find out the pH. You can reverse this and work out that the concentration of hydrogen is equal to 10 to the power of negative pH. And these three formulas are what you're going to use for all your calculations involving pH. Now, as you know, pH goes from 0 up to 14. And the diagram on the right-hand side shows you how much hydrogen OH is in each solution based upon its pH. So as you have a lot of hydrogen ion, you get a very low pH. That means you don't have much hydroxide. As you go into the basic region, you get a lot of hydroxide, so therefore you don't get much hydrogen ion, and therefore you have a large pH. Alright, that is all well and good to say, but what you need to know is how to use these. So I've got a few examples that I've recorded of me doing questions involving these three equations, and we'll look at how we can put these equations into action now. So sit back and, or if you want, grab a pen, because the next bunch of questions are attached to the back of your notes, and you can follow along with these questions and look at how it all works. So have a look at this and have a listen to me explaining it. Alright, answering pH questions. So you're going to be doing a lot of calculations, so you need a calculator, and you need to get a pen, and you need to write some stuff down. So, first of all, when you're doing any calculations, you need to know the formulas that you're going to use. So the formulas we're going to use, which are the equations we're going to use, deal with pH. And there's three of them that you need to know. You need to know, first of all, pH is equal to the negative log to the base 10 of your hydrogen, or hydronium if you will. Alright. You also need to know the ion product rule, which is the concentration of hydrogen times the concentration of hydroxide equals 10 to the power of negative 14. Alright, that's at 25 degrees Celsius. And pretty much for everything that you're going to do this year and pretty much all of next year is at 25 degrees Celsius. You're going to assume that it's that it's at that temperature. The other one is the concentration of hydrogen equals 10 to the power of negative pH. This is basically the opposite of the log one, so you can do that. So once we have these equations down, we're going to look at how we can manipulate these and work out our answers. First question, find the pH of a 0.5 molar solution of hydrochloric acid. So let's write down what we know. We know the concentration of hydrochloric acid equals 0.5 molar. Now, as hydrochloric acid dissociates, it breaks up into one hydrogen and one chlorine. I'll just write that down here quickly. HCl breaks up into H plus and Cl negative. So for every one of these, you get one hydrogen. So the concentration of this is going to be equal to the concentration of that, because one of these will break up into one of these. So that is equal to the concentration of hydrogen. Alright? Now we have the concentration of hydrogen because it's equal to that, because it's a strong acid, completely dissociates. That means our pH will be equal to negative log to the base 10 of hydrogen, which is equal to the negative log to the base 10 of 0.5. Alright, I chuck that into my calculator. So where are we? Negative log. Now notice on the calculator it's just the log button, because this naturally says it's log to the base 10. And we put 0.5 in our, oops, not 0.05, negative log bracket 0.5 bracket equals, and we get our answer as being 0.3. So our pH for this thing is equal to 0.3. If I'll go into, it's only one significant figure, so it's just 0.3. pH doesn't have any units, so that's fine like that. Now, notice the main thing in this, we needed to know that hydrochloric acid broke up into one hydrogen, so therefore the concentration of this was equal to the concentration of that. Next one, sodium hydroxide is added to a flask and then filled with 400 ml of water. We're going to find the pH of this solution. Now, what am I going to be using? I've got sodium hydroxide. Now when this breaks up, we get sodium plus and hydroxide negative. So therefore, we need to work out for our concentration of this. We got 5 grams, we've got a volume of 0.4. So what I'm going to do is, first of all, from my grams, I'm going to work out number of mole, because I need to. Number of mole equals M over Mr, which equals 5 divided by the molar mass of that, which is 23 plus 16 plus 1 is approximately 0 and 4. It's 40. 5 divided by 40, calculator again, 5 divided by 40 equals 0.125 mole. That's number of mole of NaOH. Notice I'm writing down what I'm finding out, so number of mole of NaOH. Concentration of NaOH will be equal to N over V. Now my number of mole is this, equals 0.125 divided by my V, which is 0.4 litres, 0.4. I chuck this in. Now notice I've got this. All I need to do is press divided by. I've got answer divided by 0.4. Gives me 0.3125 capital molar. Right, and that's my concentration of NaOH. Okay, now I've got my concentration of NaOH. Let's look over here. One sodium hydroxide breaks up into a sodium and one hydroxide. So that means my concentration of sodium hydroxide is going to be equal to my concentration of hydroxide ion. This is because it's a strong base and it'll completely dissociate. So now I've got my concentration of hydroxide. I'm looking for pH. So what I need to do is find my hydrogen ions, because remember my equation dealt with hydrogen. I use my ion product rule for this. I go concentration of hydrogen times the concentration of hydroxide equals 10 to the negative 14. So therefore my concentration of hydrogen equals 10 to the negative 14 divided by concentration of hydroxide. I do this and I put in my value for hydroxide, 10 to the negative 14 divided by 0.3125 equals what? Trusty calculator. 10 to the power of negative 14, oops, I'll just go bracket 10 to the power of negative 14 bracket divided by 0.1325, which is what it is, equals what? And I get 3.2 times 10 to the power of negative 14 for some strange reason. Apparently that's right. Anyway, that is that, and that's my concentration of hydrogen ions. So, now, I've got my concentration of hydrogen ions. I go to my pH equals negative log to the base 10 of hydrogen, which equals, so what I'm going to do is going to go negative. I realize I have answer there, so I'll delete that. Log. Then I'm going to go bracket, I'm going to shift, ants, not that one. Alright. Let me just work this out again, sorry again. 10 to the power of negative 14, bracket, divided by 0.3125 equals that. Okay, so now I'm going to go and use this answer by going negative, take away my answer, log to the base 10 of my answer. Now use answer because it gives me a more accurate reading. And that gives me my pH, which is about 13.49. There's my pH there. So what I've done is I've looked at how this dissociates. Obviously most of this is not needed, alright? And in a real exam or real question, you'll have more space than this to do these calculations, so you can write them out neatly. So that's how to do that question. Moving on. pH of a solution is 3.5. We've got to work out the concentration of hydrogen and hydroxide of this solution. How are we going to do that? Look at our three equations. We're trying to work out something and we're given a pH, so we're not going to need this one. We're trying to work out the concentration of hydrogen, so we're going to use this one here. So concentration of hydrogen equals 10 to the negative pH. Our pH is 3.5, so the concentration of hydrogen is equal to negative 10 to the power of negative 3.5. That will be in molar because it's in concentration. We also need to work out the concentration of hydroxide. We've got our hydrogen, so therefore we can use our ion product rule. So we go concentration of hydrogen equals, times concentration of hydroxide equals 10 to the power of negative 14. Therefore, concentration of hydrogen, hydroxide, which is what we want, equals 10 to the power of negative 14 divided by concentration of hydrogen. We bang in our number here, and let's have a look at what we get. Important thing is use of brackets in this question here. I'll just quickly do that. 10 to the negative 14 divided by 10 to the negative 3.5. Okay? Use of brackets. Bracket 10 to the power of negative 14, bracket, divided by, bracket, 10 to the power of negative 3.5, bracket. I'm putting both top and bottom in brackets. This just helps for the calculator's sake because otherwise it stuffs up, and that's normally where you go. So, we've got our concentration of hydroxide, which is 3.16 times 10 to the power of negative 11. Alright, I can work this out on my calculator as well to get it to a nice format. 10 to the power of negative 3.5 equals, 10 to the power of negative 3.5 equals 3.16 times 10 to the power of negative 4. So therefore we have our concentration of hydrogen using this equation here, and concentration of hydroxide using our ion product rule. You're going to need to know how to convert and move between these things as well. Alright, now it's a fun one. This one's going to take a bit of effort, but we're going to work through it. 10 ml of 1 molar sulfuric acid was diluted to 100 ml. Find the pH, the hydroxide, and the hydrogen concentration for the diluted solution. So, first of all, we've got a dilution here. So we got C1V1 equals C2V2. We're starting out with 1 molar, so C1 equals 1, V1 equals 0.01 litres. C2 is what we want to find out, what the diluted solution will be, and V2 equals 0.1. We bang this in and we get C2 equal to C1V1 over V2, and we work out that it's going to come to 1 times 0.01 divided by 0.1 equals, what's it equal? 0.1 molar. And we know that as well. We just look at it and we see that it's diluted by a factor of 10, so therefore it's going to be diluted by a factor of 10. You can cut that out if you want, if you understand how dilutions work. Now this is a concentration of H2SO4 diluted. Okay, sorry, can't see that? Now you can. So this is diluted H2SO4. Now, in a perfect world, this being a strong acid, what it's going to do is going to dissociate twice because it's a diprotic acid. So therefore, you're going to get, for every one of the sulfuric acid, you're going to create 2 hydrogens. So if our concentration of our diluted sulfuric acid is this, our concentration must be twice as much as that. So that means, for our concentration of hydrogen plus equals 2 times 0.1, which is 0.2 molar. So that's because as we dissociate one of these, we get 2 of those. So for our concentration here, we get twice as much concentration there. That is this done. Good. Our pH is equal to negative log to the base 10 of hydrogen. This means negative log to the base 10 of 0.2, and we work that out in our calculator. Negative log to the base 10 of bracket 0.2 equals, our pH must be 0.6, if we're rounding it. There it is. And then we work out, so that's that done. Our concentration of OH, we use our ion product rule, which I'm writing out now, 10 to the negative 14. So that means our concentration of OH equals 10 to the negative 14 divided by concentration of hydrogen, which means 10 to the negative 14 divided by 0.2. Pen is running out. So therefore, we get 10 to the power of negative 14 divided by 0.2 equals 5 times 10 to the power of negative 14 molar for that, for our concentration of hydroxide. So, there we have how to do these questions. If you just look at it like this, it's nothing. Alright, it looks like a whole bunch of calculations. But what you need to do is follow through my steps of what I've done. Look at each individual thing, and you'll notice what I'm writing out is what you should be writing out when you're trying to answer these questions. I'm going to highlight a few little things here. I'm going to highlight this. What I'm doing is when I'm getting an answer, I'm writing what that answer means. Okay? I'm writing the concentration of sulfuric acid, which is diluted. Up here you can see I've always written concentration of hydrogen plus. Here you can see I've written concentration of OH negative. In this messy little example here, I've done the same thing again. I've still written out concentration of sodium hydroxide. I've written out number of moles of sodium hydroxide, just so I know what's going on. This not only helps you when you're trying to go back and look at your answers and see if it makes sense, but also helps me when I try and correct it because I can see where you're going and what you're trying to do. So hopefully this helps in terms of how you're going to do these questions, and I'll look forward to reading what you have to write and your questions that you actually answer. Alright, so that's all the calculations that I've done. So hopefully you have an idea of what's going on. this is just a summary page and a few key questions that you can do for each area of the summary. The first part is to know that acids donate protons and bases accept protons, and that you have these things called conjugate acids and bases, and these are formed after the exchange has happened. So after an acid has lost its hydrogen, it becomes a conjugate base. After a base has accepted the hydrogen, it becomes a conjugate acid. And the questions that you can do with this are 1, 2, 4, and 5. Ignore number 3 because it's a pretty stupid question in the first place, and you won't get asked something like that in the test. Moving on to strong acids and bases. You need to know that strong acids completely dissociate. That means that if you've got a HCl and you're putting that into water, every single one will break up into a hydrogen and a chloride ion. And whereas weak acids, they only partially ionize, and you only get a very, very small percentage of the acid and the hydrogen coming apart. And you need to know the difference between strong and concentration. So strong and weak and concentrated and dilute. And these things are very different. Questions involving that come under the numbers 7 and 8. Next, you should know that there are 3 equations that deal with pH, and you need to know how to know them and how to use them correctly. With that, you need to clearly set out all your calculations. Now, in my examples, I just showed you that you should be writing down what each step of your question is finding out, because that helps you to understand it and it helps me to understand it. And even though my questions that I answered in my video are extremely messy, you can still look at it and straight away see where different parts of the question were answered. So please set your work out clearly so I can read it. And you can just go through questions at least 12, 13, 14, and 13, 30, 31, and 32. Along with these questions, there will be an Edmodo quiz coming up, not just yet because I need to write it, but you'll be able to answer that when it comes time. If you have any questions at all about these and about the calculations, please let me know, email me, or find me in class or find me outside of class, and just go through the questions. I strongly recommend, you must try some of these calculation questions by yourself before coming to see me. You must write some stuff down so I can see what you're trying to do. So you really, really, really need to work on your calculations in this part of the course because it will help you immensely. And that's it. That is acids and bases or more thereof. So all done. Take it easy. Do some questions. See ya.